Okay, so example 2, we've got to be a little bit careful with this. There's a couple of things to consider. So firstly, you might see this and start immediately thinking, ooh, trig identity. Here's one of these guys down here, these integration identities that we're given on our formula sheet. But there's a couple of reasons why that's not the case. First of all, the tan identity is a plus, and the cos and sine identity involves square roots. So that's the obvious reason. This doesn't actually match any of the identities. The other is that we're given a prompt of log p and then determine p. So we're given a prompt that this comes out as a log. And if it comes out as a log, we're probably looking at something more along this identity, which means that we want 1 over linear functions. And that means we're actually heading towards a partial fraction question. So I'm going to write this down as, I'll just rub these arrows out, the integral of 2 over, and this is x minus 2, x plus 2 dx. That's what we're trying to solve. And I want to get it as a single log. So I'll write this next step as log p, but then I'm going to go a little bit off kilter. So over here on the edge, I'm going to write, well, 2 over x minus 2, x plus 2 is equal to a over x minus 2 plus b over x plus 2. There's our partial fractions work. And I'll zoom in on this so we can use it a little bit larger. So I'm going to multiply through, and I get 2 is identical to, and that's here is identical to there, a x plus 2 plus b x minus 2. So I've multiplied through by x minus 2, x plus 2, and it's cancelled out all the fractions. And then I'm going to do this the short way. The short, I've talked about it in classes. It's short, but without a lot of logical connection way. But it does work rather than going into the simultaneous equation. I'm going to say let x equal negative 2, and I get 2 is identical to negative 4b, which means that b is equal to negative a half. And then I'm going to let x equal 2, and I get 2 is equal to 4a, and then the b disappears, and that's not the right a, it should be a capital A, and of course a then equals a half. So now what I'm actually doing is I'm integrating, and I've got my partial fractions, a half over x, let me get this order right, x minus 2 plus, well actually it's now minus, a half over x plus 2 dx. Now the halves are annoying me, so I'm going to take a half out the front, the integral of 1 over x minus 2 minus the integral of 1 over x plus 2 dx. And then I can simplify this to be a half log x minus 2 minus log x plus 2, and then I get a plus c. And I want to write this as a single log. A half, this becomes log x minus 2 over x plus 2 because of the subtraction there in our log laws. And it doesn't simplify nicely, but a single log here will be log of the square root of x minus 2, or let's just do power of a half. X minus 2 over x plus 2. Shame it's not squared, because then we can get rid of the absolute values, plus c. So then we can say, therefore, p is equal to x minus 2 over x plus 2 square root, or power of a half, or whatever we want to do. And of course, because of the square root, it has to be positive anyway, otherwise we couldn't take the square root. That shouldn't be squared, that should be a half. So, okay, now we do have a plus c, so the question probably should have had a plus c here, although maybe I can deal with that as well, because I could make that plus log base e of e to the power of c and incorporate that in. So I don't really think that's an expectation here, but I could incorporate in the c as an e to the power of c, which is just another value. I could call it a, and then I get an a multiplier at the front. Just something to think about there. Okay, so that is, I'll zoom out, example 2.